Alright, so in this problem, I have 2 to the power of x minus 2 to the power of y is equal to 2016. So, just at first glance from this problem, I can already tell that x is greater than y because we have 2 to the power of x minus 2 to the power of y equals 2016. And if x were less than y, then this would result in a negative number. But because it results in a positive number, we know that x is going to be greater than y. So this means that we can say that x is equal to y plus some constant k. So now, if I replace x with y plus k, I get 2 to the power of y plus k minus 2 to the power of y is equal to 2016. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of y plus k, that's going to equal 2 to the power of y times 2 to the power of k. Now I have this minus 2 to the power of y is equal to 2016. Now I can factor out 2 to the power of y. So I have 2 to the power of y times 2 to the power of k minus 1 is equal to 2016. Now I can rewrite 2016 as 32 times 63. And now notice that I have an even number times an odd number. And over here, I have an even number, 2 to the power of any number is even, and I have an odd number, 2 to the power of any number is even, and an even number minus 1 is going to be an odd number. So, meaning these two are equal to each other, and these two are equal to each other. So I have 2 to the power of y is equal to 32, and 2 to the power of k minus 1 is equal to 64. Or sorry, 2 to the power of k minus 1 is equal to 63. So let's first start with 2 to the power of y equals 32. So we have 2 to the power of y is equal to 32, and 32, this is the same thing as 2 to the power of 5. So I have 2 to the power of y is equal to 2 to the power of 5, meaning y is equal to 5. Now, for 2 to the power of k minus 1 equals 63, I'm going to first start by adding 1 on both sides, so these two cancel out. So now I have 2 to the power of k is equal to 64. 64, that's the same thing as 2 to the power of 6, meaning k is equal to 6. Now remember, x is equal to y plus k, so x is equal to 5 plus 6, meaning x equals 11. Alright, so in this problem, I have 4 to the power of x plus 4 to the power of x plus 4 to the power of x plus 4 to the power of x is equal to 512. So to solve this problem, I'm going to first start by factoring out 4 to the power of x. So now I have 4 to the power of x times 1 plus 1 plus 1 plus 1 is equal to 512. Now I'm going to rewrite 1 plus 1 plus 1 as 4. So now I have 4 to the power of x times 4 is equal to 512. Now I'm going to divide both sides by 4. So then these two cancel out, and now I get 4 to the power of x is equal to, actually, instead of doing that, I'm actually going to multiply these two. So if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 4 to the power of x times 4 to the power of 1, that's going to equal 4 to the power of x plus 1, which is equal to 512. So now, I'm going to rewrite 512 as 2 to the power of 9. So I have 4 to the power of x plus 1 is equal to 2 to the power of 9. And 4 here, I can rewrite as 2 squared. So now I have 2 squared to the power of x plus 1 is equal to 2 to the power of 9. Now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x plus 1, that's going to equal 2 to the power of 2 times x plus 1, which is equal to 2 to the power of 9. Now if I distribute the 2, I get 2 to the power of 2x plus 2 is equal to 2 to the power of 9. And if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, m is 2x plus 2, and n is 9. So now I have 2x plus 2 is equal to 9. So to solve this, I can subtract 2 on both sides. These two cancel out. So I get x equals 7. And if I divide both sides by 2, I get x is equal to 7 over 2. So now to check, I have 4 to the power of x plus 4 to the power of x plus 4 to the power of x plus 4 to the power of x is equal to 512. So 4 to the power of 7 over 2, this is 4 to the power of 7, the square root of 4 to the power of 7. So if I plug in this to a calculator, I get that the square root of 4 to the power of 7 is 128. So I have 128 plus 128 plus 128 plus 128, which is equal to 512. So this is right. Alright, so in this problem, I have 5 to the power of x plus 5 to the power of x plus 5 to the power of x plus 5 to the power of x is equal to 1,000. So to solve this, I'm going to first start by factoring out 5 to the power of x. So now I have 5 to the power of x times 1 plus 1 plus 1 plus 1 is equal to 1,000. Now 1 plus 1 plus 1 plus 1 is 4. So I have 5 to the power of x times 4 is equal to 1,000. And now if I divide both sides by 4, these two cancel out, and I get 5 to the power of x is equal to 250. So now I'm going to take the log on both sides. So now I have log 5 to the power of x is equal to log 250. And if I have something in the form log a to the power of b, I can move this exponent in b to the front. So now I have b times log a. So log 5 to the power of x, I can move x to the front. So now I have x times log 5 is equal to log of 250. Now if I divide both sides by log 5, these two cancel out, and I get x is equal to log of 250 over log of 5. Now, log of 250, I can rewrite that as log of 25 times 10. And if I have something in the form log a times b, this is going to equal log a plus log b. So log 25 times 10, that's going to equal log 25 plus log 10 over log 5. And this is equal to log 25 over log 5 plus log 10 over log 5. And log 25, that's log of 5 squared. So I have log of 5 squared, and remember I can move this exponent to the front. So this is the same thing as 2 log 5 over log 5 plus log 10, which is equal to 1 over log 5. So then these two cancel out, and now I get x is equal to 2 plus 1 over log 5.